Hello there, I am KP the Math G, and we're at it again. This will be the third, what do you call it, I don't know, episode or third recording of me as being KP the Math G. Today we will be finding the limit algebraically. Last two times we found the limit graphically, but this time now we are finding it algebraically. I have a few examples I want to share with you, so let's go ahead and get started with those examples. I don't want to put the rules down, although that is a good idea to start, but time will not allow me to do that, so we're just going to go straight to the examples. If we are talking about a limit, let's just put up the limit as x approaches some number, we'll say 3. We'll put down 2x minus 1 over x plus 3. Now, when we find a limit, one of the ways you need to look for first is, can you just plug the number in to this x? That's what you're really doing, is seeing if you can just plug that number in. A lot of times you can't, but there are times that you can. This is the time that we can here. So let's go down and write it again. Limit as x approaches 3. Now 2 times 3 minus 1 over 3 plus 3. Okay, there it is. 2 times 3 is 6. We can do this right here. 2 times 3 is 6. 6 minus 1 is 5. The denominator, 3 plus 3 is 6. When you get this as this limit as x approaches some number, 5 over 6, or some number a or whatever, it is just that number. Okay. There is a rule that says that the limit as x approaches a, b is simply b. Okay, and that's what we got here. Okay, so that's the limit there. So, okay, just simply plug it in. But we're going to find some that you can't plug in, and most of the time, like I said, you cannot. Sometimes the limit does not exist. By the way, let's put this back up here again. I want to show you something. And I'm going to erase the rest of this. But let's see, what was it? 2x minus 1. 2x minus 1 over x minus, oh, I think I had plus 3, didn't I? Plus 3. Now again, 3 plus 3, we're just going to put that 3 in there like this. 3 plus 3 is 6. Our denominator is 6. We have to be very careful that our denominator is not 0. Had this been a minus 3, this would have been 0, and you know what happens if your denominator is 0. Surely in calculus you know that if you get 0 in your denominator, it's either indefinite or undefined. Indefinite means you got a 0 in the numerator and a 0 in the denominator. Undefined means you have, say, like 5 up here and then 0 over here, and that is not defined. Okay, undefined. Okay, and there's a reason behind that, of which maybe some other time I'll show you why one of them is indeterminate and the other one is undefined. Okay, I'll tell you what, I'll do it right now. How about that? Indeterminate, and I cannot spell very well. In other words, we can't determine what the answer is. 0 divided by 0. Somebody will say, well, that's 0. Well, now I can say that 0 over 0 is 27, and simply because it is the top number divided by the bottom number, and that just simply means that I can multiply something by 0 and get 0 back. Well, I can plug in 0, I can plug in 27, I can plug in 30. 30 times 0 is 0. So there's no determination. I can plug in a negative number, negative 1/2. So it's not determinate, it's indeterminate. And that's when we say it's indeterminate, because we can't determine what the answer is. It is an infinite number of answers, and so 0 over 0 is indeterminate. But now, but 5 over 0 is the same as 5 divided by 0, which means something times 0 equals 5. Well, what goes there? Nothing really. So we cannot, it's undefined. This is undefined. And sometimes we call intermediate indeterminate undefined as well, but this is definitely undefined because there's no number you can multiply by 0 to get 5. Okay, so that's, and you see indeterminate. I think a lot of times when we do limit, we get the 0 over 0. There's actually a rule called L'Hopital's rule that we get into, and we can do certain things using L'Hopital's rule. But we're going to find some like that right now. This thing don't want to stick, our magnet. My magnet is not that great, but good enough to hold for a little bit. Let's do this one. I think you'll find this one to be common. Your teacher or professor has probably already given you several limits like this. This is something that's really simple. I think you've already been familiar, and maybe that you've forgotten it. So we know that if we put 3 up down here, 3 minus 3 is 0, and we know if we put 3 here, 3 squared is 9, and 9 minus 9 is 0. So we have that indeterminate 0 over 0, and that's what we're looking for, is that. So let's see, what can we do? Well, I know that I can factor this top, or the numerator. I can't factor the denominator, but I can certainly factor the numerator. So doing that. Okay, x plus 3, x minus 3, okay, over x minus 3. And notice that you are removing, and you might say removing the 0 in the denominator is what you're doing. So now this is, we do actually have a limit here. X plus 3. Now plug the 3 in. So if you want to put the limit, you can. You don't necessarily have to at this point. 3 plus 3 is 6. Okay, so I don't know. Some teachers might want you to say the limit as x approaches 3, 6 now equals 6. Okay. If they want you to do that, then do that. Okay. I would say just put 6 down if you can see that right away. Alright, so that's one of them. Okay. Here's yet another one. Going to do probably about a couple more of these. Okay. And let's see. Let's try this. Okay. Let's try the limit as x approaches 0. Let's do 1 minus the square root of 1 plus x over x. And here again is another indeterminate. If you plug 0 here, this is 1 plus 0. Square root of 1 plus 0 is 1. So the square root of 1 is 1. 1 minus 1 is 0. And then, of course, if you put 0 down here, you automatically have 0. So this is indeterminate here, okay? I'll just put this on the side. 1 minus the square root of 1 minus 0 is equal to 1 minus the square root of 1, which, by the way, is 0. Because the square root of 1 is 1, okay? Alright, so there it is. Alright, eraser, where are you? I had this problem. There you are. I had this problem last time. Always looking for my eraser. Well, we're going to go ahead now that we've got the indeterminate part. We're going to see what we can do about it. Well, we can do what you call taking the conjugate of something like this. Let's see what happens if we do that. I hope we don't run out of space here. We can simply do this. The limit as x approaches 0. Okay, so we might just bracket that in. I don't know. Okay, so now 1 minus the square root of 1 plus x. And then 1 plus the square root of 1 plus x. You're doing the exact same thing, the same two terms, 1 and then the square root of 1 plus x, but then you're changing that with a sign change there, from minus to plus. And of course, if you do that here, you have to do it down here as well to make all things equal. And there you go. That's really the basic idea behind that. And if you know how to go from there, you can. Let me just emphasize one thing. This is kind of like a minus b right here, and then this one here is a plus b. Okay, so if you had a minus b times a plus b, you really have a squared minus b squared. Okay, and that's what we're fixing to do here. 1 times 1 is, well, let's put the limit up here. Ooh, I don't know if we're going to have room. Limit as x approaches 0. Okay, so let's see. 1 times 1 is 1. We can just do 1 squared. Okay, a squared minus b squared. So the square root of 1 plus x, quantity squared here like this, all over x times 1 plus the square root of 1 plus x. Okay, there we go. Ooh, parentheses right there. There we go there. Alright. This, one thing, another rule that we can keep in mind is, and let's see, right, so there we are. Maybe you know, sometimes in calculus we forget even the basic rules. If we have something like the square root of x squared, that's just x. So if we have the square root of x plus 1 squared, that's just x plus 1. Okay, so here we go. Alright, so this one right here is now going to be 1 minus, put it in parentheses, okay, because this is all one unit here. Okay, so 1 plus x, no square root anymore because the square knocks out the square root. Okay, x times 1 plus the square root of 1 plus x. Okay, there we go right there. Alright, we're running out of room, but we're getting there. The limit as x approaches 0. Look at this. Let's distribute that negative over the parentheses. So it'll be 1 minus x over x times 1 plus the square root of 1 plus x. Okay, right there. Alright, well, let me erase some of this other, because we're running out of room here. Hopefully you have, maybe I have room down here. We might can squeeze it in. Okay, we might can squeeze it in down here. How about that? Okay, let's put that over here. Okay. Oh, let's see. 1 minus 1 is 0. Alright, so that's going to be the limit as x approaches 0. This is just negative x up here at the top. And then at the bottom we have, I might need to make this a little bit wider. X times 1 plus the square root of 1 plus x. Okay, now we got something going here. At least I think so. Double checking to make sure that I've done everything that I know correctly. Okay, so it looks good so far. Just making sure. I like to double check, triple check something like this, because I don't want to be wrong or steer you wrong either. Okay, alright, so let's see here. Notice that these x's can go, we can divide them out. Alright, so let's see what we got here. So actually what we have at the top, if we take this off, this is still 1. If we take this off, this is 1. Alright, actually this is negative 1 at the top. Alright, 1 plus the square root of 1 plus x. Okay, now we're getting somewhere. Okay. Alright, now let's plug 0 in right here. So the limit as x approaches 0, negative 1 over 1 plus the square root of 1 plus 0. And if you know 1 plus 0 is 1, square root of 1 is 1, 1 plus 1 is 2. So I am going to have to erase something now. So let's just do that. Okay, let's go ahead and erase. Sorry, I don't have a bigger board. Let's see. I can go this far over. Bear with me as I erase. Takes up time, doesn't it? Okay. Alright, here we go. Alright, now we got the limit as x approaches 0. Alright, so we have at this point negative 1 over, actually 1 plus 1. Alright, which is the limit as x approaches 0, negative 1/2, which is negative 1/2. Okay, there it is. If I made a mistake somewhere, let me know, but I think everything is a-okay. Alright, so that is how you do that. You have to, if this had been 1 plus, you would have came across with 1 minus. The same thing, okay? But this was minus, so you had to do a plus, and that's what we did. We brought that down here. We already had this up here, and that's how we got down to that, okay? Alright. Okay, pretty good problem there. Alright, gonna do, I think, one more problem, and I think maybe 2 more, and we'll bring our lesson to a close. Okay, here we go. Actually, I'm scheduled to go to the Y with my wife here in a few minutes, and I had to do a little exercises, even though it's got to try to lose his belly, you see, but oh well. Alright, I think I like food a little too much. Okay. Alright, so let's do a trig function. I made this one up yesterday. Alright. I think this may be our last one. thing about it, if you know the graph of sine and cosine, or you can put it in your calculator, we do know that sine of pi is 0, and tangent of pi is also 0. So we still have that 0 over 0 that can't determine. Okay, all right, indeterminate. All right, so let's see what we can come up with. We got that 0 over 0. And by the way, incidentally, that is true. If you graph sine, there's your 0 right there at pi. Okay. Okay, and if you did the same thing with tangent, you would run into 0 as well. Okay, so let's see if we can see if I can find my okay. Alright, here we go. In trigonometry, we know, or at least we should know by trig class, that tangent of x is equal to sine of x over cosine of x. So one thing about it, you need to go back to your trig identities in case you have forgotten them. And so that's one way to do this, probably the best way to do it, unless somebody can show me better. This is a good way right here. So what we have here is sine x divided by sine x over cosine x. Okay, and this limit as x approaches pi, this is sine x divided by sine x. I like to do it that way. Okay, there is a rule that says that a divided by b is equal to a times 1 over b, and that's what we're going to do. We're going to flip that b over. Sine over cosine just becomes cosine over sine. So what we have here is sine x times cosine over sine. And notice what happens here. This is actually sine over 1. You got a numerator, you got a denominator. You can simply divide those out. What we have here is, let me erase this. Sorry. I hope you have that written down. Okay. Now we're down to just the limit as x approaches pi, cosine of x. So the limit as x approaches pi, cosine of pi. Well, you can do that in your calculator, or you can think about the graph. Cosine of pi is -1, I do believe. Let me double check that. Okay, so on my graph, cosine starts up here. It does something like this. So this is pi over 2. This is pi, and by the way, this is -1. This is +1. So yes, cosine of pi is -1. Alright, there it is. So this limit is equal to -1. Okay. I don't have time to show anything else really. I did want to show the squeeze or the sandwich theorem, but I don't think time is going to allow us to. So anyway, I appreciate your time here. I am going to try to cut my time shorter because I think the last lesson was 47 minutes and 48 seconds. And that's really right, 47 minutes, 48 seconds. So I want to cut those a little shorter. Okay. Alright, maybe next time I will show the squeeze theorem, but I do want to get into limits of infinity, or maybe, well, the horizontal and vertical asymptotes are what I'm really wanting to look at, and some limits that just don't exist anyway. So, okay, that's it right there. Okay, so as you found out, sometimes you can just plug in a number. See if you can. I mean, this right here, you want to see if you can do that here. But if you get that 0 with 0, you're going to have to do a little bit of something there. In this case, we had to use the identity of tangent, get sine over cosine. In other cases, we just had to factor or get the conjugate of something. So those are the basic ideas behind finding limits algebraically. I hope this has been helpful. There are others that we could look at, I know, but these should help you along the way. Hopefully they have. Thank you so much, and you folks have a really good day.